Think back to how most of us learned in school. You sat at your desk, absorbing facts from blackboards and textbooks. Even when computers arrived, the goal was largely the same. Education meant learning the fixed rules of operating a machine or specific software. Today, our children live in a completely different environment. They carry almost every piece of information ever recorded right in their pockets. The hardest part of learning today is no longer finding the answer. It is figuring out how to make sense of the overwhelming flood of data they see every single day. To address this exact challenge, the National Education Policy is updating how we prepare students for the world they actually live in. Middle schools across the country are introducing two new subjects, artificial intelligence and computational thinking. If those names sound intimidating, you can take a deep breath. We are not asking seventh graders to sit in a dark room and write thousands of lines of complex computer code. Instead, we are giving them a mental toolkit. We want to show them how to break down new problems and invent their own creative solutions. The focus stays on the way students process information, building a mental habit of logical thinking that lasts long after any specific software goes out of date. Before a machine can act smart, a human has to know how to think logically. This is what we call computational thinking. It starts with decomposition, breaking a giant task, like a vacation, into manageable pieces, like booking travel and packing. Next, pattern recognition finds rules connecting them. Finally, algorithms build step-by-step instruction manuals, solving the problem the same way every time. Notice how none of that involves a computer. Computational thinking is simply a structured framework for advanced human problem-solving. Once students understand how to think logically, they get to apply those skills to artificial intelligence using simple tools that require absolutely zero coding. In machine learning, we start on the left with a messy pile of raw data. Instead of programming rules, we train the machine with lots of examples. On the right, the trained AI automatically classifies and groups new shapes into perfectly organized boxes. The students learn a crucial lesson here. AI is a powerful matching engine, and its output relies entirely on the quality of the data humans choose to feed it. This brings us to a critical question. What happens if an AI is only trained on a very narrow or incomplete set of examples? This introduces AI bias. If a machine only learns from smooth paper, it fails to recognize a crumpled piece, leading to incorrect and unfair decisions. To prevent this, we keep a human in the loop, ensuring a real person is always there to check the decisions and catch any blind spots a machine might miss. Machines cannot be trusted to run entirely on their own. Human judgment is the absolute requirement for fairness, accountability, and safety. So the entire curriculum boils down to 3 actions: think through a problem logically, train a tool with good data, and keep a human involved to monitor the results. This approach strips away the magic and mystery of artificial intelligence. It reveals AI to be another manageable tool in a student's belt. This gives students a clearer look at how digital tools actually function, making the technology they use every day feel more understandable. These exact skills are what professionals use right now to spot illnesses in healthcare data or manage smart traffic lights in our growing cities. And in every single one of those real-world applications, a responsible human must remain in control to ensure the system works for everyone. These students are becoming the responsible, critical thinking leaders who will guide our automated future.